n squared is equal to 4 times some other number, let's say a squared. Does that make sense? But that gives 2m squared equals 4a squared, or m squared equals 2a squared. So m is even, by the same logic. So what? I have a common factor, this is a contradiction. Yeah, I can show you all the contradictions. These are all the symbols I know about contradiction. They all mean contradiction, but there might be another. Anyone know another? This is what an Australian teacher taught me, this is a Hungarian taught me this, and this is American. Right, this is like two implications of colliding, this is C. And this one's, I don't know, it's just like I've struck you, I don't know, it's like Zeus struck down your group or something. I don't know, no, so there's a funny story, this is my favorite, because I learned it in Hungary, but this is also like when, the middle of Harry Potter mania. But my point is, yeah, so these, you can use all these symbols, but great. But this is a contradiction. So this tells me some root 2 cannot be a rational number. And then I finished my proof. Right. But the reason I actually went through all this trouble is, I mean, even I shorthanded this a bit because I wanted to get through it. The point is, this is roughly what I do expect from you on your homework. And the reason is because this is so readable. Like, you can go through it a second time and more or less understand what's going on. Does that make sense? Great. Wonderful. So this is telling me that root 2 isn't in Q. But let's actually make more precise what I mean by Q has a hole in it. A little bit more. It's not going to be rigorous yet. It won't be rigorous till like next week. But so let's consider two sets. This is still the very first page of rooting. Rooting manages to do all this in a page. But actually does this in about a paragraph. Let's consider two sets. So now this is my chance to make sure you guys know set notation. I'm going to take the set A, which will consist of all rational numbers R such that R is positive and R squared is less than 2. And I'm going to take B such that R is so yeah, this is R is positive and R squared is greater than 2. So the reason these guys are going to come up throughout the lecture, but the reason I'm bringing this up is so we've already seen it as holes in it, right? Something else also has a hole in it, that's Z, right? But if I take a set like any set in Z, it has a largest element and it has a smallest element, right? Take your so as long as it's bounded above, right? If I tell you, so for instance, this set is bounded above. This set, like you can tell, has a upper bound and a lower bound. So this should have, so if this was a set of integers, this would have a largest element. Yeah? And if this was, or this would have a smallest, and this one should have a largest. Is what I'm saying. Sorry, does that make sense? What I'm going to prove to you is the opposite. So here's the thing, and this is the last thing I'm going to prove before I actually start making this course concrete. A has no largest element. And B has no smallest element. I'm actually only going to do one of the proofs because the proof for both is the same. But so the reason I'm bringing this up is I'm going to ask you guys. So this is a good example of, let's say this was your homework problem, right? This is a good example where just jumping right into it is not going to be the best way to go. You want to first think about what you're going to do. So let's just I actually have a proof for both of them simultaneously. Well, let's just think about it. Let's say you were going to prove A has no largest element. What statement are you going to prove?
Suppose I found the largest element, then I can find another one.
You could go to right. So you're going to contradiction, but you actually don't need to. That's roughly right. So this is something I really find useful when I'm writing proofs. I write these it's not appropriate. It says want to show. I write want to show statements. What they do is they basically write one mathematical statement of what I want to do in this step. Okay? So I want to show statement here, as Faye already kind of pointed out. Well, I want to show A doesn't have a largest element. The easiest way to show it is take something in A. And so I want to show there exists Q in A such that Q is bigger than A. Or Q is bigger than P, right? if I show you given any random element of A, I can find a bigger element of A. I've shown it has no largest element. Does that make sense? And again, this is another of those things. And you guys already have a lot of experience with proofs. I'm fine if you skip these things. But if you don't, this is like the very first thing. Even now when I'm doing my research, I'm like, oh, I really need this symplectic form to, or this symplectic manifold to be tangent to this vector field or something like this. I write down. I want to show this. I write down what that means in as precise mathematical terms as possible. And the reason I do this is because it tells you where to start. Because it tells me. Or maybe we'll say, yeah, it's a left. But the point is, it does tell me I'm going to start with left P, B, and A. Right now, I'm going to try to show you that there's another, there's a Q in it that does. So this is where you guys are going to first, so this I think is your first taste of an analytic proof, and this is why. Now, this is my proof. And I'm going to digest or give it to you, give you an explanation of what's going on. Let's say Q was equal to P minus, P squared minus 2 or equals to. And if there's any one statement I think I can say welcome to analysis, this one. This is the biggest problem with analysis proofs at first. Once you get used to it, it's pretty cool. You're going to see these random things where I'm just going to say, oh, look at this thing. And hint, this will work. But, I mean, at this point, you're like, what the hell? Where did that come from? And I'll tell you where that came from. That came from, maybe 30 minutes, an hour, 2 hours of thinking about it and trying to come up with the right element. But because I'm writing a proof, I don't show you those 2 or 3 hours of work. I just write this thing down because I already know the answer. And I will now show you this will in fact work. And in fact, this thing will work for B as well. That's how cool this is. I'm not that smart. It's actually rooted that smart. I just copied it. But I wanted to point this out, and the reason I'm pointing this out, and this is something that comes up a lot in analysis. Sometimes the answer is just or one answer, because the other thing is this isn't the only answer. I guarantee you if I was only showing it for A, I could come up with other answers. This just happens to work for both A and B, so it's really great. But the thing is, this happens a lot in this book. They'll just say, let H be this, let this variable be equal to this, and it's these ugly expressions. And you have no idea why he does that, and it works. Sometimes it's a really nice thing to just try to go back and figure out why this works. And we'll do that at the end. And maybe the thought process came from to make this work. But anyways, so I claim this Q works. So what do I have to show for this Q to work?
Q is
an A, which means what? So again, I wrote another one to show you. Maybe again, you don't have to put these in your final answer. This is just what I do in my scratch work because it gives me a direction. But I want to show Q is an A, or otherwise, what do I want to show?
Q is
greater than 0, and P squared is less than 2. So I'm going to try to show this now. Now again, this is a mess, but anyway. So is Q greater than 0? Let's try to show the first one. How well can you guys see it here? Everybody in the back, can you see this? Oh, this. Can you see what I've? Can you guys see that? Okay, cool. How about so I'm gonna make a line right here. Yeah, I hate this table. You can't even move it. And I think if I could move it, I'd probably get in trouble. I'm just gonna go to the other thing. But I'm keeping that line so I don't drop right under it. So let's show Q is greater than 0, or is Q greater than 0? Yeah. Why is that? Yeah, why? Exactly. Since P is an A, P squared minus 2 is negative. And this is positive because P is positive. So I'm subtracting a negative number. So it's bigger than P. So yes. Well, so again, this is more notes. I'm doing this more for scratch paper, but I'm showing you roughly how the proof would go. I would just write, well, since P squared minus 2 is less than 0, Q is greater than P, which is also greater than 0. Does that make sense? So in fact, so far we have almost everything we want. And here